Excellent. Mary Clara, read the first one.
The limit of f of x as x approaches 3 is 5.
Perfect. What's the other way we could say that, guys? There's two ways.
Limit of f of x as x approaches 3.
Perfect. So you say the limit of f of x as x approaches 3 is 5, or the limit as x approaches 3 of f of x, right? It doesn't matter the order we say those two things in. Okay? All right, next one here. What does this mean if the significance of limit as x approaches 3 of f of x is 5, but we also know that f of 3 equals 2? Let's start with f of 3 equals 2. What does that mean? What does that mean? F of 3 equals 2. This is pre-calc, guys.
That's the limit of f of x.
Before we get to the limit, just f of 3 equals 2. What does that mean in pre-calc?
But in the graph, f of 3
To the left.
It's 2. That's it, right? Like, don't overthink it, guys. It's just pre-calc. Okay, now what does the limit part mean as x approaches 3? Is 5.
That 3.
that it can't reach more than 5.
Okay, so when it's a limit, you're going to put an open hole, okay? If it's a limit, that means that from both sides, it's got to be approaching that 5. Does it matter the way those two lines are drawn?
No.
Not really, right? Because in this case, they didn't give us any more information. That's all we have. So what is the significance of this that I just drew then? What does that mean if the limit's 5 but the function's 2? What does it have? It has a limit, absolutely. It also has a value. Are those two things the same? No, so that means that this has a discontinuity. So we could say, I guess, f of x. Right? Because if those two things are different, that means it's discontinuous. It's not, like there's a discontinuity. In this case, it's a, well, it's just a point of discontinuity. It's not a fancy one. It's not like a jump or something. Does that make sense? Ish? A little bit? All right. So, let's talk about getting into these limits that we talked about last class with the graph still, but we're going to also do it as a little bit of numeric approach because, as I said, we're going to take away the graphs as we keep going, right? So, here's our equation over here. All right. We can see right off the bat that it's got two asymptotes. We can also see that it's got a point of discontinuity here, a hole, and it tells us that that hole is specifically at -3 and 7/6. Okay? That's going to be important. So now what we're going to do is we're going to compare what we would talk about last year or previous years with what we're going to say now in calculus. So in pre-calculus, if we said as x was approaching -infinity, the graph of f of x was approaching, and if we look up here, if we go up to -infinity, or like go to our graph and then go off to the extreme left, where am I approaching? Not infinity, 2. Why 2?
Because it's y on the
Right, it's the asymptote. So there's only 3 options, guys. Infinity, a number, which is an asymptote, or -infinity. There's no other things that it can go to when we go to the extreme edges, right? It has to go to one of those 3. Unless there just is no graph, I guess. So when you have a horizontal asymptote, right, that means that as we get close to it, we don't cross it. We just get closer and closer and closer to it. So it means that as we go further and further to the left, we're going to get closer and closer to 2, right? Exactly, getting towards that asymptote. And if we go to the right-hand side, is it any different? I'm still going closer to 2 in this particular case, right? So for this one, it's 2 in both cases, right? Now, let's talk about how we can write this with limits. So here I can say that the limit as x approaches -infinity, that doesn't look like negative, let's change it. There we go. Okay, of f of x is 2, right? So we can say all of that with just our like mathematical statement. -infinity. And then the next one is going to be as x approaches infinity of f of x equals 2 as well, right? So we can write these things a little bit more like truncated or, you know, in mathematical terms. Now, what about when now we have x approaching -3 from the left, the graph of f of x is approaching something, and then as x approaches -3 from the right. Okay, so we're going to do it from the 2 different sides here, from left and right, but we're approaching -3 in both cases. -3 is the asymptote, What's the only options if we're approaching an asymptote? What do we have to go to? Infinity or negative infinity, right? There's no other option because we can't cross it. So from the left, I don't know if I like that when it's thinner like that. Let's put it back to the size. So as we go down here, what am I getting to? We're getting to 3, and what's the y getting to? Negative infinity. And then here, as x approaches 3, what are we going to from the right? Infinity, right? So from the left, we approached negative infinity. From the right, we approached infinity. Okay? What does that mean about the limit at negative 3? Does it exist? No, because like the left side and right side are different. Remember we talked about that last class? So because this is negative infinity, this is infinity, it won't exist, right? The one-sided one exists, but the actual limit won't exist. It's 2 different values. Now let's write it in calculus notation. So the limit as x approaches negative 3, how do I say that it's from the left? Plus or minus. So from the left, is it a minus or a plus? Minus. So I put a little raised minus. Of f of x is equal to negative infinity. Now for the next one, I need to show that it's coming from the right. How do I do that? Little plus sign up there, exactly, or positive. And that one's going to be positive infinity. Okay? So really, we're just taking a bunch of words that we had to use last year, and now we're saying it with just limit notation. Okay, so we're changing the way that we can write it. Now the next one we're going to do here is we're going to look at 3 from the left and 3 from the right. This is the one that was our hole, right? That's where our hole was. So let's go take a look at it. So we can see here that from the left and from the right, we are approaching the same thing, that hole. And where is that hole? Remember, it tells us, well, negative 3, but remember, obviously, guys, like x is approaching negative 3, right? Like, what is the y? That's what we're always talking about. It's not 1. It tells you. There's a 6 in it. 7, 6, right? Tells us right here that the coordinates of the hole are negative 3 and 7, 6. No, that's okay. All right, so we got that 7, 6. Okay? Why am I giving you 7, 6, guys? Because I just want you to get used to numbers that are not always pretty and easy. Okay? The more advanced we get in math, the more we need to be able to deal with numbers that are not whole numbers. Okay? So let's write that out in limit notation. The limit as x approaches 3 from the left, that's that little negative up above, of f of x is 7 sixths. And the limit as x approaches 3 with a little plus sign from the right of f of x equals 7 sixths. What does that tell us about the limit there if both sides are equal? Does the limit exist?
Yeah.
Exactly. That limit exists because it's the same from left and right. Say what? Oh, okay, sorry. Does that all make sense to everybody, or is anyone confused? You're confused. All right. What's confusing, guys? Both of you.
So, no, it's a simple question. So when it comes from the left, I put a minus on top, and from the right, up.
Exactly. And if there's nothing, where does it come from?
To infinity.
No. Both sides, right? So if we want to specify from the left, we put the little negative. If we want to specify from the right, we put a positive. If we don't want to specify at all, then we put nothing.
What here is this 3, what is the x part is negative?
The coordinates says negative.
Ah, we did these ones all backwards, didn't we? I see it. No, I see what you mean. So here's what we did, I think. This one was the one that was supposed to be 7, 6. So here's what we're going to do. We're just going to change these to positives and change these to negatives. Do you see what we did? We literally just did them backwards because I'm half asleep, apparently.
And you're recording a video. It's wrong.
Meh. I'm not redoing the video, man.
No, it's change that.
I can't. If I do the video next class, will be the next topic. Guys, it's not that big a deal. All it is here is that, yeah, we mixed up the 3 and negative 3, right? When we approach 3, like if you want, we can redo them. You want me to redo them? We can redo them. Nope. All right, we're gonna redo them. These guys can't handle it.
So,
They can't handle it. We're gonna do it again.
Mister, I have a question.
They can't handle it. They need it redone. Oh, now they all hate you guys. Mistakes were made. No, I'll do it real quick. So from the left, guys, look, it's not that, don't worry about it. You can just change it easily. -3. This was the one that was 7-6. All you gotta do is, you guys, you can literally just put arrows on yours, right? This one would be 7-6, which means this is the limit as x approaches -3 from the left of f of x equals 7-6. And this is the limit as x approaches -3 from the right of f of x is 7-6. Matthias, next time if you notice that, man, tell us sooner. As soon as you told us? Okay, fair enough. So now we've got the limit as x approaches 3 from the left of f of x, and we went to -infinity. And then the limit as x approached 3 from the right of f of x equals infinity. There we go, we fixed them all. Aren't you excited?
I'm so happy when you fix it.
Yeah. Well.
It's so good. It's so much better.
Isn't it though? Isn't it? All right, let's write this one down. Then I'll give you a chance to like write it and then we'll talk about it. So, if the function at a approaches the same value from the left and right, then the limit exists even if the function at a is different or does not exist. Yeah, I'm going to let you guys write it, don't worry. Martine, do you have that written down, buddy? Mariana, you got it written down?
Yes.
Okay. Yeah, sorry, I know. In Spanish, it's arroba. In English, it's at. That's why I do it, guys. You can try, but I'm never going to break that habit. I've been doing it for like 30 years. It's not going to change.
It's easy to write in the computer.
It is. It's also easy to write at. Technically, it's a little bit easier. At.
No, because you have to hold. You have to hold.
Yeah, but one of those is just your pinky. Your pinky doesn't normally do anything when you're typing except hold shift. Do you type like this? Oh my god. Guys, you type like this. And so your pinkies are the ones that hit like the arrow keys, the enter keys, the shift keys. Oh no. Alright, you guys are all done now. I can hear enough of you guys are finished. Alright, so let's try and, well, let's talk about it first, sorry. Okay, so what all this means, guys, is what we've already been talking about yesterday and even the beginning of this class. Basically, the limit exists if both the left and right side are equal. If they both approach the same thing, there's a limit. If they approach two different things, Manolo, what does that mean?
It doesn't exist.
Yeah, you should pay attention, buddy. Okay, all right. So let's talk about this one then real quick. So if I look at this one, before I even take a look at any of the questions, what is the only place on this graph that's like potentially interesting that I should check? The line, right? Like obviously if it's just on this line, like this part of the curve of the function, the limit exists because it's continuous. So the only place where it might be interesting is at this asymptote. So let's check it out. What is the limit as x approaches 2 from the left side of f of x? infinity. What is it from the right side? Right. Now, the other part is, what is f of 2? So pre-calc, not calculus, not the limit. What is it just like, is the function at 2? What is the function? If it's an asymptote, what is it? Huh? Guys, if it's an asymptote, is there a function? Does it exist there?
Yes.
No, right? Like it's this dotted line that I can't cross. So here it's undefined. Guys, that's pre-calc. That's not new. If there's an asymptote, it doesn't exist.
So if
Okay?
it has a line like that,
It means the function doesn't. The limit can, and that's what we're going to see here. Because does the limit exist? Well, yes, it does. And what's our reasoning? Well, the left side equals the right side. And the best way to say this is equals infinity. They're both going to infinity. That's like the easiest way. Remember we talked about the fact that you have to justify your work, and that's one of the grades you're going to get? Guess what, guys? This is that justification part. Can you tell me why? Well, left side equals right side equals infinity. Oh, don't say that. That's so harsh.
I wouldn't have wrote it down now. I didn't. So it's much easier.
Cool. You like wrote it in words?
Yes.
Yeah. See, it's not wrong, but this is the easiest way to do it. Okay? All right, let's take a look at that next one. So in this one, what is the interesting part that we're probably going to be looking at?
The whole.
The whole, right? So at x equals 2. So sure enough, as we approach 2 from the left, so the limit of f of x as x approaches 2 from the left is what? Where's that hole? 2. As we approach 2 from the right-hand side,
I got confused.
Wait.
it's because you guys are talking. I'm not going to answer your questions. Stop talking and I'll answer your questions. No, really not. You guys are just talking. That's what makes it feel fast, guys. Okay? Guys, from the right-hand side, what am I approaching? 2, right? Now, what is f of 2? Pre-calc, not calculus. Pre-calc. What is it? It's -3, right? There's this dot way down here. Yeah, right? So there's a hole, and then all of a sudden, there's this discontinuity down at -3. So, does the limit as x approaches 2 of f of x exist?
Yes.
Yes, why?
Left side.
Left side equals
Left side equals right side equals 2, right? So, perfect. We know it exists. What don't you understand, man?
Why is the number x in the what is the number? No. Yes.
Here? Yeah.
2 is what? X
Well,
or
we're
y?
Guys, the limit is approaching, so x is approaching 2, which means that that's here.
So the
And then I want to know what y is. Guys, you really got to remember, f of x means y. So if I'm taking the limit as x approaches 2 of f of x, it means I want to know what y is.
So when the number is the number like below is like looking that on the x.
Exactly. And I want to know what y is. All right, next one. What's the interesting point here again?
It's curve.
It is a weird curve, and where is the weird curve got a weird thing going on?
Infinity.
Not at infinity.
No,
It's got discontinuity. This one's a jump discontinuity. Where is it?
-3.
Well, that's the y value. Let's talk about the x value. X is where we like know where we're going. That's the map to tell us where to look. Y is the solutions. Huh?
3.
Now, once again, you guys are giving me the solutions. Where are we looking? So x tells us where to look. What are we looking at? At 2.
Oh my god.
At 2, right? Because 2 is where we've got this weird thing going on where there's a discontinuity. So that's where we're going to take the limit. So the limit as x approaches 2 from the left. Go to 2, go to the left, find the graph, chase it towards 2. What do we get to now? Yes, I've heard several of you say it. Now we're going to do the limit.
So
As-
can you repeat that?
So we're taking the limit as x approaches 2 from the left, right? That negative. So what I do is I go to 2. I go to the left of 2. I find the graph. I trace the graph until I get to 2. And then I'm asking what is y. So in this case, 3. Okay? And then on the other side, we're going to do exactly what Andres said at the beginning. Right? So I go to 2. I go to the right. I trace the graph. And now I'm approaching not 3, but -3. Okay? And let's see how good your pre-calc is.
3.
F of 2 is 3. Why is it 3 and not -3? Or nothing? Exactly. This one's filled in, right? So we go to the one that's filled in.
Yes, sir, but when you go down and all.
Pero,
What do you mean?
Like from the right, you went up to -3 and no, down to -3 and like up.
Well, because there's no graph here, I can't just make my own graph, right? I gotta trace the graph,
You can trace the line up.
but I have to approach 2. If I'm going this way, I'm not approaching 2, I'm running away from it. So I have to approach 2. Well, because this is filled in, this is not. This means don't include it. This means include it. Okay, that's the pre-calc. You guys gotta come see me later if you need more help with that one. Does the limit exist?
yes.
Why? No? Okay, we're hearing both now. Which one's which? There we go, guys. Yes, no. And the reason is because the left side does not equal the right side. And the way you might show this one, because you can't say equals, you would show that like the left side is 3, which does not equal -3. That's the best way to show this one. Okay? Does that kind of make sense to everybody? No? Well, at least you're honest. At least you're honest. No, if you have a question, I can talk about it. Okay. Yeah. Yeah. All right, let's take a look at this next one. So graphical analysis. All right, so now we got a much crazier looking graph. We got a whole bunch of interesting points on here. Let's see. Does anybody remember what this kind of graph is called from your pre-calc? Piecewise. It is called a piecewise graph because it is a bunch of different functions, right? Maria Clara, what do you think would be one of the interesting points that we're probably going to look at on this particular graph?
-5.
Yep. Probably going to look here because there's a discontinuity. Where else do we might look? Juanita, where do you think?
On the other side, same.
That's 2.
On the 2? Good. What's the last one? Anyone get the last one?
-1.
Possibly -1. I mean, there's a dot there, so they might make us look there. But where's the one that like they're definitely going to make us look at? Because there's not 4. It'd be right here.
On top when the line touches.
Right. Anytime there's a horizontal or vertical asymptote, that's when they're going to look usually, right? So see this vertical asymptote at -3. They're probably going to make us look there as well. So let's go see now. Where are we looking? First one. The limit as x approaches -3 from the left. So if it's from the left, we're just going the one way. So -3 is that asymptote. We go a little bit to the left of it, find the graph, trace the graph. Where are we getting to? Infinity. See, you guys know these things. You're catching on. You're smart. All right, limit as x approaches -5 of f of x. So -5. This time it doesn't specify one side. And this is the one that Maria Clara first told us. So from the left, I'm getting to 4. And from the right, I'm also getting to 4. So what's the limit if they're both sides are equal? Exactly. Okay, so as we approach -5, which is right here, from both sides, we're approaching the y value
But doesn't have a hole.
of 4. There's a hole there. The limit can exist if there's a hole. The function may not, but the limit does. Does that have anything to do with the limit? Because that's not the limit, right? The limit is about where we're approaching, okay? So, yeah, the function, you're right, is at 1. The function, like, if we look at f of -5, it's 1. But the limit is 4, because we're approaching 4, even though the function has this discontinuity.
So we just look to the ones that have the line.
Exactly. All right, now let's look at -1, right? That's the next one. Limit as x approaches -1. All right, -1. Oh, look at that. They did ask us about that weird dot that you guys mentioned. So in this case, if it's continuous, there's no discontinuity. The limit's going to exist for sure. From left and right, we're just approaching -1, right? There's nothing weird going on there, so we don't even really have to think about that one very much. It's just -1. Now, I don't know why this next one is C again, but it is. We have 2 C's. Okay. The limit as x approaches -3. So now we're approaching -3 from both sides. We already did the left. What was the left? Yeah, and what about now as we approach -3 from the right? Right. So in this case, if it approaches two different things, that's does not exist. Now, you don't have to write this part out, but I'm going to write it. Actually, maybe you should write it out just so you can kind of make sense of it, okay? So this is the limit as x approaches negative 3 from the left of f of x, and we want to know, question mark, does it equal the limit as x approaches negative 3 from the right of f of x? And in our case, what was it from the left again? That's when it went up. Positive infinity. And the other side, when we went from the right? So those things are not equal. So up here it says, if a limit does not exist, state y. The easiest way to state that, remember, was that for this one, the left side does not equal the right side. And then we can say infinity does not equal negative infinity. Now, the way I wrote it here is correct as well. So if you're asked to write it with limits, you should probably show it this way. If it just says, like, tell me why, then you can just write this. But I wanted to write both so you see them. Yeah.
So we should change A to does not exist.
Change which one?
A.
No, A still exists because this is only one side. So the one-sided limit still exists. Okay?
When it comes from both sides, it doesn't exist.
Exactly. All right, guys, I want you to try D, E, and F on your own. We're just looking at 2 from the left, 2 from the right, and 2 as a whole. Give it a try, and then I'll quickly go through them afterwards to see if you got them. Okay, so give those ones a try. When you're done, you can look up. When you're done, Manolo. He's already looking up here. Yep. So check them from left, then check it from the right, and then you're going to put those two together to see if it exists as a whole. So,
Is this last the last one correct? Because I know this one is negative infinity. Is this one?
yeah, this one's not.
Could you explain that?
If you go here and
Oh,
you
it's that
follow
one.
it up, it's going to go up to where?
I don't know.
Well, if it's going to, yeah, infinity. It's going to go up, so it
Oh, so it's just
diverges.
infinity?
Yeah, exactly. You got it.
Yeah, I thought it was this one, but I said no. It's going up and to the side. That's why.
Yeah, so you got to look at like the extreme right of your graph and then keep going. Yeah. You bet. All right, who got those ones right? Anybody?
Sir, so
Without
when
cheating and looking at my answers?
If we do the
One person. Oh
it
boy.
would be
2, 3, 4. Okay, a little better. What?
when we do the limits example, it would be no, because there's 5 examples.
Hang on, guys. I can't hear her. What?
When we have the limits example, the next summary, the limits example.
We will do a little bit more work with limits, yes. A little bit.
Yeah, but like the first exam equals the limits, or no?
No, because that's pre-calc. Completely different. We'll talk about it after. All right, guys, let's take a look at these ones real quick. Okay, if you have questions about those, you can ask. But basically, from the left, we got 1. From the right, we got 6. That means that they don't equal, right? If we look up here, you can see it. From the left, I approached 1. From the right, I approached 6. Yep. All right, last 2. I'm going to approach negative infinity, and then I'm going to approach infinity. Okay? As I approach negative infinity, I'm going out this way. What am I getting close to? The horizontal asymptote, which is 2. All right, so that one's going to be 2. Now, what about when I go to the positive infinity? So this is the extreme right. Find the graph on the right and just kind of extend it up. Where is it going? Positive infinity, right? It's going up. It's just going to keep going up forever. Okay. Now, the last thing we're going to write here is just what these are, because we've talked a little bit about it, and we'll talk more in the future, but this is what we call end behavior. So when we take the limit as x approaches negative or positive infinity, it means we just want to know what's going on at the extremes of the function. What is the end behavior? Only 3 options, remember? So we have infinity, negative infinity, or a number, which is really a horizontal asymptote. Okay? All right, guys, that's the lesson.